Hello everyone, welcome to my channel Chemistry is Fun. Today we will discuss a topic which is given in the syllabus under the chapter of hydrogen and its compounds. We will study about the compound hydrogen peroxide. In this video we will study about the structure and preparation of hydrogen peroxide. Now this compound hydrogen peroxide, it was discovered by Thenard, L.J. Thenard, and he discovered it by the action of sulfuric acid on barium peroxide. This compound was initially called as oxygenated water because, as we all know, the molecular formula is H2O2, so it was named as oxygenated water. If we see the structure of hydrogen peroxide, it was found by Thenard that if we study 17 parts by mass of hydrogen peroxide, that is H2O2, it will give us 9 parts by mass of water and 8 parts by mass of oxygen. See, if we have 17 H2O2, so 17 H2O2, from here we can have 9 parts by mass of water, that is H2O. 9 H2O and 8 O2. So this is 9 parts by mass of water and 8 parts by mass of oxygen. From here we can deduce the empirical formula to be OH and molecular formula as H2O2. So this is in short hydrogen peroxide. Now there are two suggested formulae, structural formulae for H2O2. In one you see it is like water molecule normal with a coordinate bond between one oxygen atom to the other oxygen atom. This was King's formula. Another formula in which the structure can be given as HOOH, this is Bayer's formula. So there are some evidences to support both the formula. If we see King's formula, so here you see there is a coordinate bond between the two oxygen atoms. So this can explain the oxidizing properties of H2O2 because there is an oxygen linked by a coordinate bond and it can be easily lost. So this explains the oxidizing property of hydrogen peroxide. Another is Bayer's formula. Bayer's formula is HOOH. So in this we can explain that hydrogen peroxide behaves as a weak dibasic acid. You see there are two hydrogen atoms which can be replaced. So it can explain the characteristic of hydrogen peroxide as a weak dibasic acid in which either one hydrogen or both the hydrogens can be replaced by any univalent basic atom like sodium. So then we can get NaOH. There is a possibility we can have this type of compound, NaOH or NaOONA, that is Na2O2. So there is evidence for both the types of formula. So hydrogen peroxide can be considered as a tautomeric mixture of the two forms which are in equilibrium. Now the question arises, what is a tautomer? I told you about tautomeric mixture. So tautomers are structural isomers which can be interconverted by the relocation of a hydrogen atom within the compound. So here one hydrogen atom, if we shift from its place, like see here we can explain this hydrogen atom, if it is shifted and kept after O, we can have HOOH. So within the compound only, if there is a relocation of a hydrogen atom, we get two different structural isomers, then they are known as tautomers. So these two structural formulas of hydrogen peroxide are tautomers. So hydrogen peroxide is a tautomeric mixture of these two forms we have just discussed, and both the structures will be in equilibrium. Now when we study the structure, we find that the single bond O2 oxygen bond, as we can see in the figure I have drawn over here, this OO distance is 1.48 angstrom, and this molecule also has a dipole moment of 2.1 d. So it means that the molecule, the entire, all the atoms are not lying in the same plane, so the bond dipoles are not cancelling each other. If the bond dipoles cancel each other, like if OH bond dipoles will be there, if they cancel, overall there will not be any dipole moment in the molecule. But since in this compound there is a dipole moment of 2.1 d, it shows that the four atoms are not in the same plane. Moreover, you see the OH bond distance is 0.97 angstrom. These values are just to give an idea about the structure. Memorization of the values, I think, are not desired. The HO bonds make an angle of 97 degree with the OO bond. The oxygen hydrogen bond, the angle between this angle, you see in the structure, you can see my red angle I am making now. The HO bond and OO bond, between them there is an angle of 97 degree. Now the H2O2 is existing in gas phase as well as crystalline phase. The structure of H2O2 is different in gas phase as well as crystalline phase. In the gas phase, the angle between the O bond and the OH bond is 94.8 degree. This bond, this theta I have written, that is 94.8 degrees. And if I represent O bond distance as R1 and OH as R2, in this phase R1, that is OO bond, is greater than OH bond. This is not the case in crystalline phase. In crystalline phase, you see here R1 bond is smaller. R1, that is OO bond, is smaller than the OH bond. And the angle between OO bond and OH bond, this angle which I represented by theta again, it is 101.9 degree. So the values of the bond distances as well as the bond angles are little bit different in the crystalline phase as well as in the gas phase. Both are not the same. Now the second topic which I stated we will be discussing is the preparation of hydrogen peroxide. So there are two types. One is the laboratory preparation and we will also see the manufacturing methods. For the laboratory preparation, H2O2 can be prepared from sodium peroxide, that is Na2O2, either with ice cold water or with dilute sulfuric acid. If it is with ice cold water, we get sodium hydroxide and hydrogen peroxide. But if it is with H2SO4, we get Na2SO4, sodium sulfate, along with the preparation of H2O2. Hydrogen peroxide can also be prepared from barium peroxide. For this, we need to treat it with dilute sulfuric acid at around 0 degree C. If we are using hydrated barium peroxide, we get better result. Hydrated means there will be some molecules of water of crystallization. Water of crystallization is there, it is BaO2.8H2O. With H2SO4, we get barium sulfate, hydrogen peroxide, and the 8 water molecules will be regenerated as we see. Now in this case, there may be a small problem. If we use sulfuric acid, it may catalyze the decomposition of hydrogen peroxide. H2O2 which is formed may get decomposed. So instead of sulfuric acid, we can use some weak acid like orthophosphoric acid, that is H3PO4. If you use so, we get a precipitate of barium phosphate which can be filtered out and H2O2 will be produced. So overall reaction is BaO2 and H3PO4 gives barium phosphate and hydrogen peroxide. Barium phosphate is prepared, it will be precipitated actually, so it can be filtered and removed easily. Another process is Marx process, in which there will be reaction between CO2, BaO2 and water, that is carbon dioxide is passed through a cold solution, pasty solution of barium oxide. So since it is a solution, water molecule will be present. So barium oxide, water and CO2 which is bubbled in gives barium carbonate and hydrogen peroxide. So in this the barium carbonate is again insoluble, as we all know. It can be filtered out. It is insoluble. So barium carbonate is insoluble. We can filter it out and thus we get hydrogen peroxide. If we see the manufacturing methods, for the manufacture of hydrogen peroxide, we can use isopropyl alcohol. isopropyl alcohol, there are 3 carbon atoms and the hydroxyl group is attached to the second carbon. So it is iso group, isopropyl. CH3, CHO with CH3. So this alcohol along with oxygen under slight pressure, we get H2O2 and CH3COCH3. For this manufacturing method, little bit of H2O2 is added as an initiator. Another is electrolytic process. In electrolytic process, we have to do electrolysis of dilute sulfuric acid. 50% diluted sulfuric acid is electrolyzed at low temperatures. The electrodes used are of platinum. So H2SO4 we get H plus and HSO4 minus ions, 2 ions. HSO4 minus ions, it is an anion, it will go to the anode, it will lose 2 electrons and we get peroxide disulfuric acid. This peroxide disulfuric acid is distilled. On distillation, hydrolysis will take place and we get a distillate. In the distillate, there will be 30% of hydrogen peroxide. This is the process in which electrolysis is being used. Now see, for getting this 30% dilute concentration of 30%, how we get? Actually, when we get the hydrogen peroxide, it is quite dilute, but its concentrating process is very difficult because it is highly explosive. So what is done? The dilute solution is concentrated at around 60 to 70 degrees C on a water bath. While we do so, water is comparatively more volatile and it gets evaporated, and then the concentration comes to around 30%. So this is the method in which we go for concentration of hydrogen peroxide solution so obtained. I hope you all could understand the manufacturing methods, laboratory preparation methods as well as the structure of hydrogen peroxide which I discussed today. Thanks for watching my video. Please subscribe to my channel. Thanks for watching my video. Thank you all.